3.4. In this lesson, we're going to learn how to solve inequalities using addition or subtraction. Inequality is a statement formed by placing an inequality symbol, so we have 4 of these, between two expressions. For example, y plus 5 less than or equal to -6. The solution of an inequality is a variable is the set of all the numbers that produce true statements when substituted for the variable. You can show the solution of an inequality by graphing the inequality on a number line. So let's take a look at this. Inequality, x less than 3. In words, this means all numbers less than 3. The graph will be an open dot on 3, and it would point left, all the numbers less than 3, not including 3. And for y greater than 2, this means all numbers greater than 2. Again, it's an open dot, and the arrow will point to the right, all the numbers greater than 2, not including 2. Z less than equal to 4 in words mean all numbers less than or equal to 4. So we will have a solid dot and an arrow pointing to the left. And for n greater than or equal to 2, in words, that would be all numbers greater than or equal to 2. So we will also have a solid dot with an arrow pointing to the right. So here we have the addition and subtraction properties of inequality. This is very similar to the properties of equality. Okay? So if A is less than B, then A plus C is less than B plus C. And A minus C is less than B minus C. If A is greater than B, then A plus C is greater than B plus C. And A minus C is greater than B minus C. The same would hold true for less than or equal to and greater than or equal to. Okay, part A, let's solve the inequality. And then we're going to graph and check the solution. So to solve an inequality is very similar to solving an equation. So I'm going to subtract both sides by the opposite of positive 5, which is -5, because I need to isolate the variable to one side of the inequality. 10 minus 5 is 5. So this is complete. And now I need to graph. Because this is a greater than or equal inequality symbol, because it includes 5 due to this part of the symbol, I need to put a solid dot and point the arrow to the right. And the same holds true for the next problem. I need to add 9 to both sides. Cancel out -9 and +9. -6 plus 9 would give me +3. And that would be less than or equal to x. Now this also includes 3 because this is a less than or equal to symbol, inequality symbol. So I'm going to put a solid dot on 3 and draw an arrow to the right. Part B, compound inequality. A compound inequality is two inequalities joined with and or. To solve the compound inequality, we need to combine them. For example, x is greater than 3 and x is less than 10. I could flip this around. And I notice that I can combine these two inequalities together. And after graphing it, it will look like this. Open dot on 3, open dot on 10. And we'll have to shade in the middle. And here we have two inequalities combined already. So we can go ahead and isolate the variable x by subtracting 5 to all the sides. 2 minus 5 is -3. Recopy the less than sign, bring down the x, cancel +5 and -5, recopy the less than sign, take the difference of 9 minus 5, and that is 4. And that's complete, and we can go ahead and graph. -3, open dot, 4, open dot, and shade it in. And this one looks a little bit more complicated. That's okay, we can first simplify each. Subtract 3, 2x will be less than 6, x will be less than 3. Here, 3x will be greater than 18, x will be greater than 6. And we can go ahead and graph this. 3, 6, open dot, everything less than 3 and everything greater than 6. This will be your answer. Word problems. Okay, these are common verbal phrases for the inequality symbols. The greater than can be also read as is more than. Is greater than, is larger than, or above. The greater than or equal sign can also be read as minimum, at least, is not less than, or not smaller than. The less than sign can also be read as is smaller than, is less than, or below. The less than or equal sign can also be read as maximum. At most, not more than, is not greater than, the greatest, or save up to. By familiarizing yourself to all these different ways of pronouncing these inequality symbols can help you solve the word problems more easily. Let's take a look at an example. Astronauts. They become a NASA pilot astronaut. A NASA pilot must log at least 1,000 hours as a pilot in command of a jet aircraft. A NASA pilot has completed all other qualifications and has 250 hours logged. How many more hours must the pilot log to become a pilot astronaut? So let t equals the time. So now we need to set up the inequality. So you know that the pilot has already flown 250 hours. Then we need to find out how many more. And it needs to fly at least 1,000 miles, 1,000 hours. So I have to use the greater than or equal symbol. Now we can solve. Subtract 250 to both sides of the equation. Cancel out. Take down the t. The 1,000 subtract 250 gives you 750. Now, this pilot needs to fly for another 750 hours. Well, at least 750 hours. This is highly important. Neon. The lowest temperature at which neon is a gas, called its boiling point, is -411°F. Write and graph an inequality to show the temperatures at which neon is a gas. So let T equal the temperature. at which neon is gas. So we can simply write T is greater than or equal to negative 411. And if we graph this, we'll point the arrow to the right with negative 411 shaded in. So your answer will be the temperature must be at least negative 411 degrees Fahrenheit to be a gas. And that concludes our lesson.